Assalamu alaikum everyone. So today we are going to design the PCB for our project. Previously we made this project using separate modules like ESP32 modules, charging modules, LoRa modules, and all the modules are soldered on the PCB, and that somehow worked but looks bulky and not professional. So we are going to build a single PCB where all the basic component like only this ESP32 chip, the LoRa module, and the components on this charging module board. So all the SMD component are mounted on single PCB. Okay, so let add all the components. So one thing you must strictly follow. Um, the component we are using must be available in JLC PCB's JLC assembly service. So let's search this component. So you will select the type, symbol, and classes must be selected JLC PCB assembled. Okay, and let search this component. Okay, so we if we select this component, this is not available on this assembly service, so we cannot select no stock for this component. So we can select and place any one among the available models. So if I select this model, this is available, so let's place this ESP32, but I have already placed one, so let select. So I have already added all the components, all the SMD components required for this PCB. So let everything wired up. Okay, after huge wiring, all the connections are completed. The USB Type-C port, then the USB to serial communication IC CH340, and all the LEDs, buttons, across coupled BJTs for automatic bootloader and programming, and the ESP32 with LoRa module, the power regulator IC 3.3 volt output, and the filter capacitors for different parts, battery protection circuit including battery header and switch, power switch, and the battery charging IC indicating charging LED, and this LED indicates full charge state. Okay, so now we'll move to the next step, converting this schematic to a PCB. Okay, for this purpose, let's convert it. Design convert schematic to PCB. Okay, this schematic has duplicate prefix for components. Okay, duplicate part name, problem solved. Now let's convert to PCB. Okay, so all seems good. Let's convert it to PCB. Sorry, I'm converting to PCB. Okay, I'm using the default width and height. Okay, on the component are here. So let me make a LoRa module on the bottom layer of the PCB. Okay, the pins changed its color. Okay, let's place this one by one. Let me set the design rule. Design rule. So the default track width I will use 0.15 mm. Clearance also 0.15. Wire diameter is 0.6 mm. Okay. Wire drill diameter 0.3 mm. We add rule for power trace. Rule for power trace. This will be 1 meter. Clearance 0.2, and wire diameter 0.8, 0.4. Okay, VBus. I'm setting the rule for VBus, the power from USB socket, and the ground, battery plus, battery minus, and the 3.3 volt net power apply. Okay, all the design rule are set it. Okay, so the component placement is completed. So now we have to add some copper area just opposite side of the LoRa module and the ESP32 module. Then we have to connect the both to ground net using many vias to reduce the interference between the Wi-Fi module ESP32 and the LoRa radio module. Let's do it. So now we can run the auto run program for auto routing. Select auto route tools, auto routing. Design tool is already set. both top layer and bottom layer rerouting. Okay, let's run the program. It will take some time, so let's wait. Okay, auto routing is completed, but some traces are not built yet, so let's manually connect them. Okay, so all the connections are completed. And now let's add some ground plane for interference reduction between the USB32 module and the LoRa module. Okay, so selecting ground plane. There's first on the top here, the whole board I'm selecting. Okay, next, the bottom there. Okay, so now the board is completed. Okay, welcome back. So after hours of datasheet studying, debugging, and stressing over the complex transistor logic like the automatic boot and reset cross-coupled transistor logic, it is finally done. To be honest, the cross-coupling transistor configuration was very tricky and very common mistake for designing such microcontroller project. So the two BJT are cross-coupled. The emitter of the BJT are not connected to ground. This is a very common mistake, and the emitter basically connected to the opposite input from the CH340 IC. So now the overall architecture seems professional. Starting with from the left, the USB Type-C port used for both programming and debugging the microcontroller, and also for charging via this charging IC. Mm, The battery will be charged with this charging IC, and power will be and the power will come from this Type-C port. Here is integrated battery protection circuit for short circuit protection and low voltage cutoff and high voltage cutoff. And there's a pair of 3.3 volt regulator. Two of them are used to increase the current capacity because one of these regulator IC can handle only 600 milliamps of current. So in case of the LoRa module's peak current consumption when it transmit data, it can consume a couple of ampere currents. Because at the time of transmission from this LoRa module, it can consume several amps of current. All the components used here are available on JLC PCB. So this PCB can easily be manufactured using their manufacturer service. So this is one of the parts. Let's search it. So this part is available in JLC stock, sufficient stock, and it is $0.54. So and all the components are available in JLC assembly service. So this is our final PCB. Have a look in 2D. So well finished. Also connected multiple vias in the top layer and bottom layer ground connection to reduce radio interference from the ESP32 modules for the LoRa. So we now can export the Gerber file for manufacturing this PCB, or we can directly order from GLC, just one click. So generate Gerber fabrication file. I already checked the design rules, so no, generate Gerber file. I don't want to order it right now, so I just generate Gerber. Okay, it may take some time. Okay, done. Okay, all the resources are attached in the video description, a GitHub link of the Gerber file and the images. And if you want to build your one, you can follow this link. Thank you.